Hello, my name is Valerie McGuire, and I'm a distinguished engineer here at the Siemon Company. I was also the chief editor for the IEEE 802.3CG 10 megabit per second single pair Ethernet amendment, which, as you know, was published in 2019. This project defines the operating parameters for 10BASE-T1L, single pair Ethernet, an application which is commonly referred to by its acronym SPE. The SPE application supports 10 megabit per second transmission over balanced single pair cabling for operational technology or OT applications. These applications encompass a wide range of low speed and field bus devices such as sensors, actuators, and relays, devices commonly used for building automation applications such as HVAC, security, access, and lighting control. Broad market adoption and deployment of 10BASE-T1L will be a milestone step toward enabling interoperability and networking of traditionally siloed smart industrial OT devices with enterprise IT and Internet of Things devices. Today, I'm super excited. We're going to demonstrate transmission of 10BASE-T1L over 400 meters of familiar category-style cabling. Our demonstration application is a basic security access control system that could be found in any enterprise environment. With this system, we can control the magnetic lock on a door to grant or deny access via card reader, push button, and motion detection inputs. As an example, you can see how critical security access control might be here in Siemens data center showroom. Communication between the end devices and a PC loaded with control software will be over 400 meters of a one-pair SPE channel constructed from Siemon Category 7A cable and 4 Siemon fully shielded TERA connectors. The Siemon TERA SPE Category 7A channel is assembled from components that are all commercially available today. Let's take a look at the infrastructure topology, beginning with the controller application software loaded on the PC. Since SPE equipment and devices don't have a market presence yet, our security access control communication must first be converted from TCP/IP at the output of the PC to single pair Ethernet by a media converter. The 10BASE-T1L output signal from the media converter is patched to a TERA outlet with a one-pair TERA cord and then connected with 90 meters of solid cable to a TERA outlet located in a zone enclosure. The outlet in the first zone enclosure is connected to a TERA outlet in a second zone enclosure by 250 meters of solid cable. 35 meters of solid cable then extends from the second zone enclosure to a TERA equipment outlet. And finally, a single-ended one-pair TERA cord connects the far end of the SPE channel to a second media converter that transitions the signal back to TCP/IP for connection to the locally powered security access controller box. Our end devices are connected to the controller box with manufacturer recommended control cables. I like to refer to this 400 meter 4-connector configuration as an expanded star topology because it builds on the traditional 90 meter structured cabling link. While optional, 2 logically positioned zone enclosures can offer much needed relief and flexibility to support moves, adds, and changes for channels that are 250 meters and longer in length, and their use is highly recommended. In our demonstration, you may note that while we're only accessing one pair in our test channel by using a single pair equipment cord for the media converter connections, our permanent link, in fact, consists of 4 pair Category 7A cable and 4 pair TERA outlets. Because the Siemon TERA SPE cabling system is fully shielded, our solution has the advantage of being able to support up to 4 unique SPE applications and controllers over one 4-pair structured cabling channel, an ability that's referred to as cable sharing. Cable sharing saves material cost and more efficiently utilizes pathway space compared to deploying 4 SPE applications over 4 shielded one-pair cables. While the TERA interface elegantly supports access to 1, 2, or all 4 pairs within the Category 7A channel, The Siemens TERA SPE cabling solution is specifically designed to be compatible with one pair screw terminal and one pair pluggable interface connections at the ends of the channel. For example, in this demonstration, we are connecting each end of our 400-meter single pair channel to a media converter using screw terminals. As shown here, the media converters used in this demonstration were supplied by Analog Devices Incorporated. The media conversion boards are deployed in pairs and used to convert the signals of any of the many 10BASE-T TCP/IP devices on the market to 10BASE-T1L single pair Ethernet for evaluation purposes. So now let's take a look at the functionality of our SPE security access control system. In our demonstration, we will be controlling the magnetic lock on a doorway based on inputs from a card reader, in addition to instructions from the software loaded on the PC. Communications to and from the PC software to the controller box are converted to 10BASE-T1L by the media converter boards and are transmitting over our 400-meter Siemon SPE demonstration channel. Here we're looking at the access control user interface on the PC and the networked card reader we're controlling. Our first event is an unregistered card swipe on the reader. In this case, access denied is confirmed by 4 short, audible tones. Notice of the event travels over the 400-meter Siemon SPE channel to the PC, where it's captured in the event log window. Our second event is the swipe of a registered card with access privileges on the reader. Here, access granted is confirmed by 2 tones. Notice of this event, along with the card owner's information, travels over the 400-meter Siemon SPE channel to be captured in the event log window on the PC. Our final event is an instruction from the PC to the access device transmitted over the 400-meter Siemon SPE channel. Here, a database manager with administrative privileges remotely unlocks the door. The event log window updates to show the remote door open event, and the device confirms the action with an audible tone. This demonstration confirms successful transmission and operation of 10BASE-T1L communications over a Siemon 400-meter SPE channel. The high performance and unique cable sharing ability of Siemens TERA components means that existing installed TERA permanent links can easily be retrofitted to support SPE applications. It's also easy to specify new and generic TERA permanent links that are capable of supporting both future IT and SPE device connections using the 4-connector expanded star channel topology. Thank you for tuning in to see Siemens SPE cabling solution in action. Please come visit Siemens SPE landing page if you would like to learn more about this or any of Siemens' other high-performing cabling solutions.